We talked about reuse in sort of a general sense. Specifically, what kinds of things can be reused? The answer, anything. Macros, scripts, HTML, procedures, classes, packages, components, any piece of work that you have done could be reused. Doesn't have to be code, could be designs, could be architectures, could be test cases, could be anything that you have worked on that the result of your work could be reused somewhere else. That's reusable artifacts. There are different kinds of reuse. I call them forms of reuse. Black box, clear box, and then something in the middle that I'm calling translucent box. The distinction is here. The black box reuse, you can't see the code. All you see is the specification for the component. You see what it does. You see, basically when we were talking about requirement specification, we mentioned that you should use black box form for your requirement specifications. Well, that's the kind of form for the specification of the reusable component. So you can't see the code. You can never see the code. It's hidden away from you. All you see is the specification. So you have to decide whether you're going to be able to reuse that thing simply by reading the spec. And it specifies how to reuse it. It specifies what kind of messages you can send to the reusable component and things like that, and what it does for you, but you can't read the code. Okay? Contrast that with the other extreme, clear box, or sometimes referred to as white box. Clear box reuse, you can see the code, you can actually modify the code. So what you get when you reuse the component is you get everything. You get the spec, but you also get all the code. So you can read the code to determine whether you can reuse it or not, to see what it does. But also, if it doesn't exactly match what you need, you can make changes to it. In the middle, we have the situation where you can see the code, but you're not allowed to make any changes to it. Now, each of these three forms of reuse really has its benefit someplace. Okay. Black box. Let me talk about the clear box, right? The clear box says not only can you see the code to see whether how it will be reused, what it does, how you can reuse it, how you can access it, and if it doesn't exactly fit, you can make the changes to the code. So that's the advantage of the clear box. The disadvantage of the clear box is if you can make changes to the code, it is no longer the reusable component that you reused in the first place. So I plug this in, I've changed the code, I plug it into my system. Then 3 months later, the people that wrote that reusable component find some bugs in it, or they fix some things, they add some features to it, and they send you a note and say, an email and say, we made some improvements to the component. Here it is. Well, now I have modified the component, so I can't just take the new revised version of that component that they've produced and just plug it in, right? Because I've modified the original. So I'd have to do some work to see whether or not I can modify the new version in the same way that I modified the original one. So basically I'm stuck with the older version. And that's the downside of the clear box. Black box, you don't have that problem, right? So the advantage of the black box is whenever they come up with a new version of the component, you just plug the new one in because it fits in the same interface that the old one did. Same thing about the translucent box. The translucent box means since you can't change the code, they come up with a new version of it, you can plug it in without any modification. So that's the advantage of not being able to modify the code. The advantage of being able to see the code in translucent box is maybe it's hard to specify in a black box form exactly what this module does. It might be in some cases easier to determine what it does by actually reading the code. Of course, the downside of that is you have to read the code, and that takes a lot of time and a lot of effort, and we don't have the time to do that. So the advantage of the black box is people that want to reuse that cannot rely on being able to read the code. You have to rely on the published specification. So that sort of puts a lot more emphasis on producing a quality specification for the component if you can use black box. So translucent box is good because you can see the code. It's not good because you can see the code and you sometimes have to rely on being able to read the code without, and the developers of the module probably don't spend as much effort in writing a good specification. So the black box sort of forces the developers to create a good specification for the component, which is easier to match up with your needs. So all three of these forms of reuse has its pros and has its cons. One form of reuse, in a way, is one aspect is portability, writing portable software. So it's easier to reuse it in another environment. Right? It's one thing to reuse a component in, say, the same operating system or written in the same language, but if I have a component that was written for one environment, it's harder to reuse that in a different environment unless we write it in a portable way or achieve this portability in some way. Different ways to accomplish this. One is emulation. Okay, so the component was written for one environment, one operating system, say, um, but I want to reuse it in a different operating system. Well, if I can emulate the original operating system, then I can run the component. So there is a lot of interest nowadays in virtual machines. So it's called VM, and one of the products is called VMware. And what you do is you run the virtual machine engine, and what it does is runs on your computer, but it simulates or emulates a different computer. Could even be a different piece of hardware, but certainly you can emulate a different operating system on your computer. Okay, so I can emulate a different computer altogether, different instruction set architecture, or just the same computer architecture but a different operating system. And then I can run software that was written for that other environment on my machine. The other way is to write the software without, depending on any particular hardware or operating system, write it in to a spectrum, an abstract machine. This is what happens with Java, languages like Java and Visual Basic. So you write the program, and a compiler compiles the program down to this abstract machine or virtual machine language, machine language, and that is then interpreted by an abstract machine, an interpreter, Java virtual machine, that interprets the Java program, the class files. Okay. Or in some cases, some rare cases, you might be able to translate. So either source-to-source translation or even translating the machine language from one machine to another. That would be the case where if we had a program written, say, in I don't know, COBOL, and we wanted to translate it to Java. Right? There have been attempts to translate programs written in one language to programs in another language. This is not easy to do in an automatic way. Usually requires some sort of human intervention in that translation process. Or we could program in a language for which there is a compiler for each environment. So if you program in Ada or C, there are compilers for these languages that support all sorts of environments. And so you run the same, you compile the same program, source program, using different compilers for different environments. In any case, if you're going to do this, each program that you write is probably going to have some parts of it that are going to be dependent on the specific operating system or hardware. Things such as the operating system features, operating system references, the machine architecture references, things like that. What the key thing to do is to partition those kinds of machine dependencies into a rather small number of modules in your application. So you can take, and this is probably one of those 90-10 rules. So 90% of your components, so 90% of your system should be able to, you ought to be able to translate that over and recompile that for a different system, different operating system. 10% though of your application may have machine dependencies in it. So humans are going to have to get involved with translating that 10% of your software all into the new machine dependencies.